Hi, I'm James. I joined Ably as CTO last year, and I'm going to give you a quick intro into how Ably provides serverless WebSocket solutions to help you scale WebSockets. To begin with, let's talk about the problem space. We're focusing on the problem of reliable, low latency event distribution at the edge, including sending messages between devices, device to device, data center to device, like a broadcast, and device to data center. So the kind of use cases where this is a key problem are things like sending real-time updates out to devices, audience engagement features, and synchronized collaboration, such as what collaborative whiteboards, shared experiences, maybe group chats where you just want to send messages device to device, as well as things like gaming, tracking GPS location as a delivery driver is bringing you a package, that kind of thing. So, why WebSockets in that context? Ably offer a messaging solution, as we're going to the details in a minute, that works over several protocols. WebSockets is the biggest one by far for us, and we're talk a little bit about how we fall back to other protocols when necessary. But I wanted to start by just talking about why WebSockets are interesting in the messaging at the edge space, as we're focusing on here. So, in short, it's efficient for real-time use cases. It delivers a good user experience compared to HTTP polling, and client support is widely available. We're going to start with a little introduction about how WebSockets work at a high level, just in case anybody's unfamiliar. So WebSockets are another layer 7 protocol, a peer of HTTP, if you like, but it is distinct from HTTP, but designed to cooperate well with HTTP. So a WebSocket connection is actually initiated with an HTTP request, a handshake. That's basically an HTTP request with a special upgrade header that tells the web server to keep the connection open for ongoing full duplex communication over a persistent connection thereafter. Contrast with HTTP request response polling. You don't need to keep sending headers in the request and the response with each message. That's not necessary as you've got a persistent connection. And as I was saying, it's designed to be somewhat HTTP compatible. So there's the initial request to initiate it. It tends to work over the same ports as well, 443 and 80. Avoid help reduce issues with firewalls. You can build WebSocket solutions from scratch. There's good support out there in all the web frameworks generally. You can leverage open source solutions such as Socket.io, Redis PubSub to help you implement solutions yourself. But there's basically no free lunch. It's a complicated game, and we're going to talk about some of the challenges and how a hosted serverless solution to WebSockets might be attractive. So let's start with the software developer's perspective, the service engineer writing the code, and contrast a little bit with HTTP polling. A WebSocket connection is going to require a persistent connection to your front-end services. So the state, essentially. If you're thinking about, your application needs to sort of route particular messages to particular users, then you're going to need to find a way within your data center to get those messages to the appropriate front-end instances and store the appropriate state there. And that can be quite challenging. It's going to change the workload sort of profile of your front end quite significantly to keep all of these connections open for long periods and to have state there alongside it. Whereas you might have been able to sort of load balance on a sort of stateless, horizontally scaling solution before with HTTP requests only. Another thing to bear in mind is that WebSockets, while they are widely supported, are not ubiquitous in all environments. There are significant environments where they might not work. Certain browsers or corporate environments where there are firewalls blocking particular traffic or restricting the browsers that the user can use. And for some businesses, that will be a significant market that they need to tap into. So generally, you can't just assume WebSockets are the only solution you're going to need. You'll probably still need to fall back and detect that WebSocket connections are failing and fall back to HTTP polling in a lot of situations. There's also going to be probably a kind of design pattern change in the sense that, like, imagine you're implementing a group chat solution, or you're implementing some kind of a multiplayer game. You probably want a single WebSocket connection between each user in your data center. But what you want to do is make sure that let's say every message sent in a group chat is rebroadcast out to all of the listeners appropriately. Or if it's a collaborative editing experience, you need to make sure that all state changes are replicated to all of the other users. So that's starting to feel like a kind of pub sub pattern, which is probably not the approach that you would have been taking if you were just fielding each individual request as it comes in. And then finally, note is that WebSockets don't actually provide you with the application level protocol. What they give you is a protocol that enables you to exchange opaque blobs of data in either direction from your app to your server without reinitiating a request. Some features, desirable features of a messaging solution at least, will need more than that. If you want to guarantee exactly once delivery, or if you want to put good guarantees on ordering of messages, you'll need extra features in the protocol on top of that. So you've still got quite a bit more work to do to actually turn WebSockets into a reliable messaging layer. That was the software development perspective. Now, just looking at it from the SRE's point of view as well, we said we've now got stateful connections. Resuming stateful connections is challenging, and this is an inevitability at scale. So users and WebSocket connections do drop frequently. Users will switch if they're on a mobile phone. They'll switch from a mobile data network to a Wi-Fi network pretty often. They might go through a tunnel or experience some intermittent network issue. Or maybe your servers just get overloaded, crash, need to shed connections. And you need a way for the clients to be able to reconnect and carry on where they left off. And with a global network, that's going to be challenging. Then think about routing. When you do have, if you want a highly available service that won't fall down when a single data center becomes available, or the network issues reaching that data center, you need some kind of routing solution, fallback DNS, and that requires quite an extensive bit of work to actually make sure that your users have always got a reliable route to your servers for their connections. There's the problem of latency. You want to deploy to multiple data centers for reliability reasons, but you probably also need to do that for latency guarantees if you've got a use case where a kind of responsive experience is required. So that's something else to think about. And then auto-scaling and demand-driven auto-scaling is challenging because we just talked about how the system needs to be sort of somewhat stateful with these persistent connections. It's much easier to scale up in response to demand on a stateless, request-oriented system, whereby adding more front ends will just mean that more of the incoming requests get routed to more instances. When you've got persistent connections, you may need to sort of take on the problem of shedding and redistributing load. So there are lots of new infrastructure challenges that come in as a result of that switch. So what is Ably and how is it relevant to these problems? So Ably is essentially a serverless WebSockets platform for delivering real-time data at the edge with enterprise-grade messaging delivery guarantees. I think if there are developers on the line that are familiar with Kafka, it can be quite helpful to visualize Ably as being a kind of Kafka-like solution that you can use at the edge on that last mile of messaging. I guess if you actually did try to use Kafka at the edge, your SREs would probably not thank you for it. But Ably is essentially a system where you can use the pub sub abstraction to communicate over WebSockets directly at the edge. Your clients can connect to Ably directly, communicate with each other in a sort of serverless device-to-device fashion, and you can also integrate with servers using our integrations, which we will talk about in just a second. So essentially we have a bunch of SDKs, quite good platform coverage, 25 platforms for you to kind of integrate into your application. These are quite well, rich, well-featured SDKs. So they do a lot of the messaging protocol complexity for you, and that enables us to take care of reliability, so message delivery reliability, exactly-once delivery, things like falling back on protocols. So I'll show you some code a little bit later on, but we essentially provide you with a pub sub abstraction to program against. And our SDK will try to use WebSockets if they're available to give you that sort of responsive real-time experience. And you can send messages and receive messages using that SDK. But if WebSockets are not available, it will fall back to polling or to another protocol that is available. But you won't have to change your code. That's something that will be taken care of transparently. There are very flexible APIs. It's very unopinionated. It will enable you to implement your experience the way that you want to implement it, with us just taking care of that single slice of the problem domain, that sort of state synchronization and messaging for you. We essentially provide the infrastructure and don't too much into the application problem domain, but we do have higher level abstractions for certain use cases, which I'll talk about in a minute. Servers are of course are able to communicate with Ably via REST APIs. Well, anything can, in fact, but it's in a kind of stateless environment where you basically want to broadcast a message out to users. You can make use of our REST APIs to make a single transactional call, and then all of the messages go out to listeners on potentially open WebSocket connections as appropriate. The thing that I think is really worth noticing at this level is where Ably sits architecturally within your stack, and that is Ably is very much at the edge. So your client applications can use our SDKs to connect to Ably and can communicate with each other directly if that's what suits your use case. So if you're implementing a kind of a group chat where you just want messages to be reliably delivered between users, or if you're implementing a collaborative editing experience where the most critical thing is that as soon as a user makes an edit, another user can see it very quickly, then Ably, interestingly, just sits between your users. You can do direct device-to-device communication. Obviously, it's not literally direct; it's via our network. But that enables you to implement those tricky collaborative features in an entirely serverless way, which I think is really interesting. The thing that is particularly interesting about it is that all of the enterprise level guarantees that we offer, such as the 5 nines uptime SLA, are very close to your users. So features that you're implementing with your own backends can potentially go down without that core messaging layer being impacted. So that's something that our customers rely on quite heavily. We can revisit that in a minute. So just to summarize what's provided by Ably versus what's done by the developer, essentially you manage your application and data. We have very little visibility over the data that you're sending through. You can in fact encrypt it end to end if you want to. But what Ably will deliver is predictable performance. So we have a global network across many data centers using over 200 POPs. That enables us to deliver a global medium round-trip latency of under 65 milliseconds. We offer guaranteed ordering and delivery, including exactly-once data delivery, even after disconnections. We have highly fault-tolerant infrastructure with lots of redundancy, which enables us to offer a 5 nines SLA. And we have high scalability and availability. We're able to cope with very sudden spikes in demand if you do have a very spiky workload. So it's all of those reliable messaging layer transport problems, essentially, that we try to take off of the developer's hands and provide you with a high-level SDK that enables you to focus on developer experience and differentiating features for your application. As I said earlier, the pub/sub pattern is sort of at the core of it. We have some higher level features that I'll show you in a minute that are built on top of that. But pub/sub is kind of the base API, I guess you could see. That is, you can have any number of devices publishing onto channels, we call them. Channels kind of our topic-like abstraction, if you're more familiar with Kafka. And you can have any number of subscribers. One thing to note is that in Ably, channels are very, very cheap. You can reasonably create a channel per user or per session. We'll come on to that again a little bit later. But yeah, essentially, you have edge devices such as browsers, mobile phones. They can talk to Ably directly using our SDKs. And then we have server-side integrations that enable you to get data back out of Ably and into your data center. You can also have your services called REST APIs to send messages out to devices that are connected over WebSockets. So that's useful for the sort of audience outreach or notification style use cases. Let's see some code. I think it's easier to picture what the product really does when you just look at some code. And it's really quite simple when it comes down to what you're going to implement in your client code. So let's start with publishing to Ably. So the first line here establishes a connection to Ably. We're just using, in these examples, a plain text secret key, which is not what you would do in production. We do have a token system whereby you can issue a token from your servers based on your own authentication system, send it out to the client, and they can use that to connect to Ably with only the appropriate permissions to talk to particular channels that they're authorized to talk to. But to keep these examples simple, we're just creating a connection in the most straightforward possible way. So we have a connection. Then there's simply a channels property on that connection where you can get a channel with an arbitrary name. So we're getting a channel called test in this example. And the channel object, predictably, has a publish function where you give it a message type, and some data. So we're sending a message of type greeting with the payload hello as text in this example. Underneath, the SDK will try to create a WebSocket connection to Ably, and we'll be sending messages over that WebSocket connection in real time. In the next example, we do the exact same thing to get set up, but we're using the subscribe function instead to attach a listener, a function that will be called for each incoming greeting message. And we put a very annoying JavaScript alert dialog on the screen for every message coming in. So that's simple enough for sort of publish and subscribe messaging. And what you can't see there is that all of the complexity of message delivery guarantees, reliability, and the sort of fallback protocols and everything have been taken care of under the hood. So that's kind of the basics of the product. That's the core sort of pub/sub functionality. As I mentioned, there are also higher level features built into our SDKs for common use cases. So one such common use case is presence, and that is knowing who else is listening, who else is on this channel right now, participating in this live collaboration session or in this chat group. So we have a presence abstraction for that. Same as before, we're going to create a connection on the first line. This time we've provided a client ID, which is required for the presence functionality. But we get the channel as before, the test channel, and we subscribe this time to the presence property, and this function will be called whenever we get an enter type event on the presence for this channel. And again, we show an alert saying that a member has entered the channel. This is used typically to implement features like avatar stacks. If you just want to show these are all the people participating in this session, but all of the sort of protocol level details of entering the channel, leaving the channel, Disconnecting is taken care of, and callback functions on the client will just be called as you'd expect. Note that you call this channel presence enter function to voluntarily join the channel. So just create. It's not like a passive thing where you just, if you create that channel instance, your app is actually in control of when a user is present or not with this API. Then one other quick feature to quickly showcase, I guess, in code is connection recovery and stream history. As I mentioned earlier, network connections can be unreliable. Mobile users switch from Wi-Fi to 4G, or maybe they go through tunnels, and that causes connection interruptions. Now, Ably's SDKs will automatically reconnect when that happens. And we keep track of where we got up to, essentially, in the channel, so that when we do reconnect, we can deliver any messages that were broadcast by other users in the last couple of minutes, and call your subscriber functions, such that you don't need any special code to make sure that any state changes needed in your application just happen. So that's one thing that just sort of happens by default. But you can make use of that same feature directly yourself as well. So that channel history and rewind feature is quite useful in certain contexts, such as if you're writing a chat application, you just want to show the last few messages in a chat history every time a user connects. Then you can just make use of this rewind feature. Here you can see we create that connection object again. When we attach to the channel this time, in square brackets there, we just attach some additional parameters to say rewind 10 seconds. And that will mean that you get that subscription callback function delivering messages that happened in the last 10 seconds so that you can render them on the screen with no special handling. We also just enable you to say, give me the last 5, 10 messages, whatever you want, either time or counts of messages are supported. That's the client side, essentially. Now let's just take a little bit of a look at backend integrations. So many applications, that the core experience might be that client-to-client experience, and the functions that we were all just looking at in the code there is most of what you need. But many services will need some kind of a backend integration as well. Now, the way that we enable that is with our third-party integrations. So we have a Firehose feature, which enables you to forward data from Ably channels into things like Kafka or AWS Kinesis streams as configuration only. So you can essentially say all channels, as in this diagram at the bottom here, all channels that start with a particular name, like doc in this case, I want you to forward all of those to a Kafka topic, merging them all together. Which is relevant, which is actually quite significant, because if you think about the characteristics of Ably channels that I mentioned earlier, where you can easily create an Ably channel per session, per user, per document that's being edited, it's useful that you can then have that all fan in, merge together into a single Kafka topic, because you probably want to then distribute that load across many backend instances. And that per user grouping isn't something that you want in your Kafka topics. You wouldn't want a Kafka topic per user because they're quite expensive. Functions is another option. So we can also just call a serverless Lambda function per message. If that's your preference, again, that's configuration only. You can just say, messages coming to this channel, please call this Lambda function and authorize us to do that. There's webhooks, so for certain use cases it might make sense to just have us call a HTTP webhook and say this message just came into this channel. Again, that can be configured. And for some use cases you might prefer that we host a queue of all messages that were sent to a particular set of channels. So we support AMQP compatible queues for you to just attach a backend consumer directly to a queue that we host. Let's look at Kafka in a little bit more detail, because Kafka is very, very popular. So a common thing that you might want to do with Ably and Kafka together is essentially use Ably to extend your Kafka deployment out to the edge. So you've already got, say, some event-driven architecture in your data center that you're working on in Kafka. If you wanted to get some of those messages to go directly out to users, Ably provides you sort of a very low-code solution to that, in that we have a Kafka connector. Kafka, there's the Kafka Connect ecosystem. Kafka Connect is a framework within Kafka, for those that are not familiar, where you can plug in, pre-authored components to process events. So Ably provide a connector which you can deploy on Confluent platform or other Kafka hosts that will, in a configuration-only way, send data out to Kafka. So let's say we've got a bunch of Kafka topics in a data center, in your Kafka cluster, which is hosted in a data center. What you might want to do is deploy Ably's Kafka connector to your Kafka host and configure it such that messages going to those topics are delivered to particular Ably channels based on data that's attached to each message within Kafka. And that will mean that you can have an Ably channel per user, as is idiomatic in Ably, but use this connector to just automatically fan the data out and to use Ably's delivery semantics and our low latency and WebSocket connections to get that data out to the edge where you need it, and subscribe and consume those events using our SDKs in whatever application frameworks you need to be working with. So flexibility is kind of a big part of it, I guess. With all these integrations, we also have lots of SDKs. A lot of the value that you get comes from the fact that you don't have to do the platform adaptation for this messaging layer. You can pull one of many SDKs in. You can use integrations to connect to your data center. And the code's already there for you to just program against those same pub sub or other higher level abstractions in every environment where you work. And then there's trust, which comes from the four pillars that we introduced earlier. Predictable performance, because we have a network with hundreds of POPs worldwide and we deploy to many data centers. There's data integrity, but because of the sort of protocol that we've built on top of WebSockets, which gives you guaranteed message ordering, delivery semantics. There's the scalability on demand when you need it. If you have a load spike, we'll take care of that. And then there's the 5 nines SLA that we offer. So you can count on that layer always being there. The presence at the edge in your architecture will mean that you can architect your applications such that maybe that device-to-device communication that you need can lean very heavily on our 5 nines SLA, and you can be sure that those messages are always getting where they need to be, independently of whatever else might be going on in services that you're looking after. There's a lot of customers already making use of this service. So we have 500 customers in over 80 countries. There's a lot of names there that you may recognize. 350 million devices reached each month. Trillions and trillions of messages processed so far. The kind of use cases that customers are using Ably for at the moment covers like data streaming, chat, GPS tracking, device management and control, things like feature flagging, which we'll look at in a bit more detail now, and document collaboration, interactive whiteboards, those kinds of experiences. We thought it would really bring it to life a little bit if we talk a bit about one such customer. So Split, if you're not familiar, Split are a feature flag kind of feature delivery platform. They enable developers to safely deliver features behind feature flags and deploy control like remotely. So some of you may be already familiar with those kinds of products. Their customers are people like Twilio, Salesforce, WePay. Speed's really critical. So if something bad happens, you've deployed a feature behind a feature flag, you need to be able to roll it back really, really quickly and be certain that it happens. And so Split make use of Ably to ensure that those control messages go out reliably and quickly. Oh, this animation, I wasn't ready for that. So that gives them basically through Ably's network, they get a global sub-second kill time for a feature, which is really important to split customers. They have really high volumes, 700,000 new connections opened per minute, peaking at 10 million concurrent connections to Ably. So that spiky load profile that I was talking about is really critical. And up to 1 million messages sent out per second. And over 25 billion updates sent out each month. So quite high load and a very, very critical kind of reliability requirements. So I think I'm at time. I need to get on to Q&A.
We already have one question. From a WebSocket perspective, does that mean that there is one WebSocket connection per channel?
No, not necessarily. So there's a WebSocket connection per device, typically. If you recall the code that I was showing earlier, let's have a look. That first line where you create var Ably there, that's essentially where the WebSocket connection lives. But you can create as many channels as you want out of that one connection. So the channel itself is at the protocol. So no, you can publish to and subscribe to many channels with a single WebSocket connection.
So how does compliance get handled? How is the data secured when it goes through Ably?
Okay, so we are SOC 2 and HIPAA compliant. That's the kind of the main sort of those are the compliance certificates that we attain at Ably. You have the option of encrypting messages end to end. Essentially, Ably doesn't really need to know anything about the message data that you're sending. All metadata that we need in order to guarantee message delivery and ordering and everything is attached at our protocol level, and your data is an opaque payload that we don't interfere with. So that can be fully encrypted end to end if that's something that you need. Also, we don't retain data by default. There's a very short period where it lives in our servers, and you can configure for longer retention if that's appropriate for your use case, but you don't have to. So that can help simplify if you've got strict requirements on that.
Can you also handle GDPR compliance?
So with GDPR, I guess most of the answer that I just gave applies to that. So we don't know if your GDPR applies to personal data. We wouldn't know if your data is personal. So you can sort of treat us as a network transport layer, much like any other service you might be using over the wire. We don't specifically provide APIs to enable you to sort of delete or export data that's being stored in Ably, if you have enabled persistence, that is. So you would need to make sure that you're not storing personal data in Ably if you have sort of deadlines to delete data and whatnot. You should be mindful of what you're storing if you enable persistence.
Have loads of people worried about security. So on the third-party integration, does the rule use message payload? Is the data unencrypted then?
You can basically use a couple of things. You can use the channel name to begin with. If it depends which direction you're going in. So to go a rule going sort of from Ably channels to your data center can be based on the channel namespacing. That is the name you give the channel. They are namespaced in Ably, colon separated. So you can say basically anything that is a document or a chat session forward to this topic. That doesn't require us to do anything with the payload at all. But we do have some documentation on the message level features that you can use in those rules as well, which we should send out afterwards, Andra, for more detailed docs. Essentially, your message payload can be fully encrypted, and at that point we can't do anything with it. So it wouldn't be possible to use it to within a rule to forward to the data on. So any fields that are going to be used have to be visible to us.
How different is it from a combination of Socket.io and Kafka in the backend? Also curious about how Ably guarantees exactly-once semantic when we know there can be drop-in connections after receiving messages and failure to send acknowledgements. So maybe starting with the first question, how different is it from Socket.io and Kafka in the backend?
For the first part, the difference is essentially that the infrastructure is provided for you. We've already deployed infrastructure to many data centers and regions and POPs, and we have ways to replicate across data centers. The main difference is that this is a serverless PaaS like product where you can sign up, create an account, download an SDK, and get an API key, and away you go. You can publish and subscribe directly from your application. Whereas, if you're hosting Socket.io and Kafka yourself, you've got quite a lot of infrastructure work to do. There's a lot of material out there on how you do multi-region Kafka deployments, and I guess the TLDR is that they're all quite a lot of work, and all have different trade-offs associated with them. That's kind of the main difference. The second part of the question was about exactly-once semantics. We know there can be drops in connections after receiving messages and failure to send acknowledgements. Yeah, this is going to get detailed. I think we should perhaps point to the appropriate. I think we've got some blog articles that we can send about this, but the summary is it's about the state that I think we retain in the SDK on the client side and in the server that enables us with the metadata that we've got in our protocols to figure out where we've got up to, where the subscriber's up to. I do think we've published some articles about this, though, Andrew, so maybe we should include it in the.
We do. Another question, we have customers who are hybrid cloud or on-prem, or who are multi-cloud, so like a combination of AWS and Azure and other things. If we have customers using their own premises and we build something on Ably for them, will it be feasible to send messages directly to their infrastructure? How does that work?
It's going to depend a little bit on what exactly they're doing on-prem versus what they're doing in the client. Let's say, looking at the client side of things, if the customer's got on-prem services that they're communicating with through a corporate network, and you're using Ably to do messaging between clients, client side, then that's potentially not impacted. Where the challenges are going to come is when you want to sort of get data out of Ably and back into an on-prem service. At that point, it's going to depend, I guess, on what services are being hosted on-prem. You could expose Kafka so that we can forward to Kafka, but we enable you to just provide us with an endpoint for Kafka with the appropriate connection authentication details. So that could potentially work. Or you could use some kind of an intermediate. Like I know all of the cloud providers have got a kind of hybrid model that enables you to get data in and out. So I think we would need to sort of look at the use case in a little bit more detail and get somebody from our team to advise on that, because it will vary hugely based on what's being hosted.
If we build on Ably for our customers and we want to separate one customer from the other, can we do that?
I'm not sure if I'm answering this at quite the right level, but at the lowest level, separating one customer's data from another could be as simple as just making them communicate with different channels. And you can set permissions in tokens that you issue through Ably's token auth system, such that one customer that you've authorized with your auth system can only communicate over certain channels. You could also add encryption to that if that's not sufficient. You could, if that's the right sort of level of customer, different users of the application but communicating over channels, then that's probably the right way to do that. But there's also the possibility of separating further using different Ably accounts if it's more if you want something higher level than that. I think maybe a little bit more context on the use case might be needed to advise on that.
Seems like there aren't many other questions coming. There aren't any other questions coming. As always, we will send an email to everybody with the recording. And if you have any questions or something related to specific use cases, just reply to that email. It will come back to us and we will reply in detail.
Okay. All right. Well, Thanks for joining, everybody. Good talking to everyone.